Hi everyone, my name is Slobodan Milanko. The tool I'm going to be presenting is WUDA. It helps visualize and transform rotations in real time with Quaternions and smart devices. In today's talk, we'll discuss inertial sensing, what is it, common applications. We'll highlight the associated difficulties of using inertia to study movement. We'll then introduce Quaternions as a solution to bridge the gap. We will see Quaternions in action using our tool WUDA and conclude with a quick summary. Think of inertial sensing as the study of motion. Researchers today build revolutionary applications by tracking acceleration, angular velocity, and perhaps angles. Some examples include activity discovery, posture recognition, gesture, habit, and safety detection, and the one we're all familiar with, step counting. Out of the box, manufacturers often provide two data collection mechanisms for inertial sensors. The first is a computed list of angles, such as Euler or Tate-Bryan angles, and the second is raw sensor readings. However, both of these techniques can be quite limiting. For instance, Euler rotations suffer from pole singularities, sequence-dependent outcomes, and difficulty of transforming the signal. Raw sensors, on the other hand, present a limited description of motion and are often noisy if used alone. Come Quaternions to the rescue. Think of Quaternions as a structure with four components more suitable for describing motion. Their interpolation properties and compact algebraic representation make them an efficient solution for various devices. They can also perform arbitrary rotations about an axis and are often constructed using sensor fusion algorithms for more accuracy. Due to the difficulty in portraying the four-dimensional space, however, we need a tool to help leverage this technology. Today, we rely on a three-dimensional unit sphere to describe rotations embedded in Quaternions. WUDA is an interactive tool that helps visualize motion by rotating points using Quaternions. The first illustration shows them as dark purple dots on a unit sphere. The sphere embeds an irregular polyhedra with a user-driven number of faces. The faces build a heat map, and the interface is interactive, including move and zoom functionality. WUDA also allows the user to visualize angles and transform their signal using a control panel. With this interface, it is trivial to rotate the y-axis by 45 degrees and observe the impact in real time. Let's observe the tool in real time. In the first video, I am wearing a smart device on my wrist and performing a barbell curls exercise. My arms go up and down while holding onto the weight. WUDA replicates this pattern digitally. We can also zoom in and observe the trace inside the sphere. We can also check the angles of different axes, which are especially advantageous for estimating joints. The heat map also updates in real time, giving us a glimpse into the most popular faces. The real-time dial for the axis also resembles the movement of the barbell. WUDA also allows us to compare patterns of events. In this example, trainees complete different exercise. Notice how the first two are more similar than the latter. This ability enables us to cluster different activities together. Transforming the motion signal can also be useful. In the first two images, the barbell travels from the hips to an orthogonal position to the body. The slope becomes more negative, indicated by a green arrow, until the weights reach the chin when they're positive. It is often helpful to transform the signal to make the event we observe easier to detect. In this scenario, we apply additional rotations so that the last step has a negative slope. In conclusion, inertial sensing is a powerful bridge between computing and motion. However, it is also challenging since visualizing rotations is not very easy out of the box. Quaternions are an excellent way to describe inertia, but are difficult to visualize. WUDA is a tool that helps reduce that challenge and allows researchers to study and manipulate signals in real time as their experiment is happening. Thank you.